Hi, it's Mr. Allen. Today I want to talk about the commutative property. It comes from an old French word commuter, and I apologize if I just butchered that pronunciation, but that word means to substitute or switch, and we see the root of it right there. So what does that mean mathematically? Well, it's true. This property applies to the operations of addition and multiplication. So for example, 5 plus 3 we know is 8, but I can switch that and rewrite that in another order, such as 3 plus 5. 3 plus 5 will also equal 8. So for the operation of addition, the commutative property holds true. It also holds true for the operation of multiplication. 4 times 6 we know is 24, but 24 is also the product of 6 times 4. So it doesn't matter how I write that, I can substitute or switch those numbers without messing up the result or changing the end quantity. So commutative property is true for addition and for multiplication, but it's also true for subtraction. Not in the traditional sense, of course. 10 minus 5, that is not the same as 5 minus 10. However, if we think of subtraction as adding the additive inverse, I could write 10 minus 5. I know that that's going to equal 5. I could write this as negative 5 plus 10, and that's going to be 5. So I can still, switch around these add-ins in this case to get the same result of 5. It's not traditionally true for subtraction, but again, because the definition of subtraction is really just adding the additive inverse, adding the opposite number, we can make the commutative property work even when we have a minus signal there. So that's the commutative property for us. And again, it comes from the French word commuter, which means to substitute or switch.